Thousands of years ago, our ancestors believed that the earth was flat. This was so until my boy Pythagoras, around 500 BCE, came around and said, "Nah, it ain't." Unfortunately, he died right after he invented the triangle and was never able to prove that the earth was indeed not flat. A couple of weeks later, in the 300s BCE, Aristotle got bored after coming up with rhetorical strategies for kids 2,000 plus years later taking AP Lang, so he sought out to prove Pythagoras' fantasy. He used common sense like ships disappear over the horizon, and this concept of gravity that pulls you down. Except, that volume of physics wasn't released until the 1600s by Sir Isaac Newton when an apple tried to assassinate him. So instead of gravity, he put simply that things converged into the earth. This man's basically gave hope to a greater number of people that maybe they weren't living on a huge pancake on top of a giant turtle. So the next day in 200 BCE, another dude with a long ass name that I can't pronounce came around and stuck a stick in the ground and figured out the circumference of the earth. His value was 40,000 kilometers, or put simply 40 quadrillion nanometers. But anyway, to this day, this ancient dude with this stick had a percent error of only 0.07%. I don't know about you, but I think that's pretty massive, plus 50 respect. With this value, we can then derive a formula to find the volume of the torus Earth.
Alright, so this is the circumference of a circle, and the circumference of an Earth is 40,030 kilometers. And to get the radius of the Earth, you want to set the circumference equal to that formula, and you end up with 6,370.972 kilometers. And then for the volume of the sphere, you got the formula 4/3 pi r cubed, and the volume of the Earth is 4/3 pi, and then we substituted this radius into the r, and we got 1.083 times 10 to the 12 kilometers cubed, and this is always a constant volume.
Yay, we figured out that the volume of the Earth is, open parentheses, insert value here, close parentheses. But as you may already know, intellectuals from our era have made yet another insane scientific breakthrough. The Earth is actually flat, again. It devolved into a two-dimensional shape because of global warming. Fortunately, in the recent years of the 21st century, a hero rose up, and that hero's name was Neil deGrasse Tyson, who was powerful enough to disprove flat earthers. He was so massive-brained that he made it look easy. In an interview with Chuck Nice, when asked, "Is the Earth flat?" he put it simply that we have video from space of the rotating spherical Earth. This blew up the internet. Society was going wild until, parentheses, insert name here, parentheses, came out with the absolute truth about the shape of the Earth. That the Earth is that it isn't flat, it isn't a sphere, but rather a torus.
Alright, so now that we have the constant volume of the Earth, we take the equation for the volume of a torus, and we combine these two to find the variables that we need to know for the Earth in its torus form. Now we have to make some assumptions first, such as the ratio to the big R to little r of the torus equation is going to be 2 to 1, meaning that if you take a conic section over here, the diameter of the circle is going to be exactly 2 r's, and it's going to be exactly 1 r from x is equal to 0. So from this, we can rewrite this as little r is going to be 1 times r, and big R is going to be 2 times r. Manipulating that equation, so you can get pi times big R squared times 2 pi times 2r.
Because we still haven't gotten video proof of the rotating torus from the outer space or circumference, CES, we will have to be using Stick Dude, Eratosthenes' calculation of the spherical Earth's circumference to find the radius and finally prove our theory, the donut theory. Alright, so this is the equation of the circle, and these values we got from this circle. And remember that r is not a variable, variable, but instead it's a constant. And then once you have these values, you want to plug these values into the equation of a circle. And then you want to simplify it down to isolate x. And this equation is the equation we use in the washer method. Alright, so the first method we used was the washer method. And in order to do this, we plugged in pi times the integral of negative r to r, and then in the integral, the root of r squared minus y squared plus 2r squared minus negative root of r squared minus y squared plus 2r squared dy. We got these equations from that equation over there. And the next step we did was we started simplifying. And to do this, first we converted these two negatives into a positive. And then next we combined these two to make 2 root of r squared minus y squared plus 2r squared dy. And then since 2 is a constant, we pulled that out and we got this is our final answer. And once we got this, we plugged it into a calculator and got our volume, which as expected was 1.03 times 10 to the 12th kilometers cubed.
For our next method, we have shell method to find the volume, and the definition of shell method is 2 pi from the integral of a to b times x by n f of x, and x being the center of the rectangles in the method, and the f of x being the function. The function is f of x is equal to square root r squared minus parentheses x minus 2r parentheses squared, which is the area of a circle simplified down into the f of x, or solved for y, as we proved earlier. And then the integral, we get the volume is equal to 2 pi from the integral of r to 3r times x times parentheses square root r squared minus parentheses x minus a parentheses squared dx, which a is just 2r for simplicity's sake in the integral. Dx, we multiply it by 2 because this integral is only half of a torus, so we need to multiply it by 2 to get the full volume. And our calculators are too weak to handle it, so we had to plug it into the Wolfram Alpha, and we end up with our constant volume from before. For shell method, we derive it from the area of a circle formula, which we isolate y because y is equal to f of x, and we end up simplified down to this equation.
Okay, so for the math project, we already got down 2 of the methods. Which one do you have?
I did washer.
Wash method. So you had shell?
I had shell.
Shell, cool. That leaves us with one other method that we have to choose. This method doesn't work, right?
Nah, because that's gotta be with no radius, or inner radius.
Okay. What could we use?
I don't know, man. McLeod doesn't teach us anything. I can't think of another one.
Okay, I mean, Remont, no.
I mean, good luck with coming up with another one, dog.
Yeah.
What do you mean? You're not? I help you guys come up with that.
I mean, we
good
both
luck.
did our methods. So.
Yeah.
Yeah, but like, it's a group project.
Yeah.
Exactly. So you have to do your part now.
Yeah.
Are you for real?
Yeah, we're for real.
No, come on. But I came up with the idea of the torus, right? So you guys are just like, yeah, wash method.
Yeah, but have you done any math yet?
Yeah, have you done anything?
Yeah, sure.
That's what I thought.
Alright, so finish your part.
No.
We're
We're
gonna leave you be.
Thrilled up.
You
No,
got
ideas, just ideas. Only
I'm
ideas.
sure you'll come up with plenty.
Oh, well,
Integrals, yes. Indeed.
I've returned 5 years. 5, 1, 2, 3, 4, 5 years after you guys banished me from your mathematical kingdom. With the solution to the third method on how to solve the volume of the Earth in its donut shape. You will hear me now.
Who are you again?
This should be in page 3.
Okay. Oh, you're that Brazilian swimmer.
that's me.
greater than Calc, and like we can have
Yo.
Howard's greater than McLeod.
On my part.
Your whole part?
Yeah, I put a plus sign where it should have been a negative.
I mean, that's the entire.
We gotta read it. We gotta
the
read
entire
it.
thing. I've been working really hard on this, and I'm really happy to show you. Are you ready for the big reveal?
Yeah. For real?
Yeah, dog.
I can't do this.
It'll be funny. Come on.
We're in the end game now. For the final reveal, the third method.
But the volume of the torus.
The sum of all positive integers converges to negative. Wait, this isn't.
Oh, my bad. Wait.
The third method for the volume of the torus. And sure enough, when we plug it into Wolfram Alpha, we get the final answer.